Hello, hello, hello. Good morning. How you doing? Welcome back to another stream. Today is Monday, the 3rd of November, and today I'm going to be going through TMUA Paper 2 of 2022. Hopefully, I do a little bit better than last time. So a lot of people will sit down, have looked at the questions beforehand, prepare the perfect solution, and present it to you so you know exactly what's going on. You can go find them for that. That's not what I want to do here. I'm doing these as completely live, unseen solves so that I can put yourself more in your position and think, all right, how am I going to work this out from not knowing what to do? How can I use my exam technique? How can I put together a full run? So last time I got 14 out of 20. And I remember a lot of that was me just not considering a lot of the edge cases and thinking very deeply about the problem. And there's one thing I want to correct from last time before I go into this solve, which was about the contrapositive and the converse. So in fact, let me get my screen shared. And I'll kind of go through that first. So going through, just checking you can see it. Good. All right. So I'll reintroduce the if-then logic that I used before. So there's usually a statement. So let's consider the statement, for instance. I had a cheeky Google for a good example, and it was saying, like, if it is raining, then the ground is wet. So if it is raining, then ground is wet. If that is the statement, the way I would lay that out is you have the if on the left and the then on the right. So it's raining or it's not raining. And the ground is wet or the ground is not wet. If it is raining, then the ground is wet. That is true. But it could also be not raining and the ground could be wet for some other reason. And if it's not raining, then the ground is not wet. If that is the statement, let's talk about what the converse of the statement is. For a converse of a statement, you flip around the if then, and then you can evaluate whether that's true. So the converse would be if ground is wet, then it is raining, which is obviously not necessarily true. Just from your common sense and just real world understanding. But I want to talk about how I use, and also let's talk about what the contrapositive is. Which is when you do the same thing, you take the converse, but then you negate both sides. So if ground is not wet, then it is not raining, which is certainly true. And what we find is the contrapositive is always true if the statement is true. So that's some of the theory, but let me use more of this mapping idea that I like to use just for my own brain. So what this statement is really saying, because a general mapping would have a true-false relationship going to the true-false relationship on either side. So a general mapping would have all of these. But what this is saying is if it is raining, then the ground is wet. So what it's saying really is we want to get rid of that cross path. So if we were testing to see whether this statement is true, that is the cross path we would need to test. We would need to say, well, is there any situation in which it is raining and the ground is not wet? For instance, if they've put up a tent or something, or some sort of covering. But equally, we can talk about the reverse of that, which is if the ground is not wet, then it is raining, and test whether that is true. Now, the statement and this contrapositive are really saying the same thing, which is why they are both true. If it is raining, then the ground is wet means that this dashed cross mapping doesn't exist. And if the ground is not wet, then it is not raining. It means exactly the same thing. It means that this cross term is not there. And so I use this mapping more to explain necessary and sufficient. If it is raining, then it is sufficient to say that it is wet, the ground is wet. And for the ground not to be wet, it is necessary for it not to be raining. If raining, then wet. Not wet only if not raining. So this mapping is what I'm going to be using a lot through my run, probably, depending on what questions come up, to try and make sense of everything. If you have any questions about this and how it could be used, for instance, in any specific questions, feel free to drop those in the comments and I'll respond. But yeah, I just wanted to sort of clear that up about converses, contrapositives, and use of mapping to understand what's happening. So I'm stopping sharing there, and I'm going to set up now. Okay. So in fact, let me stay there. I'm just going to move down. Right, now we're going to do the run. I'm going to go from the front. I'm going to set a timer for 75 minutes. I'm not going to take individual split times. But I want to as well. So thinking about how I did it, because if you're in a similar position to me and you want to improve your score from a 14 to get higher, you got to think about what happened last time, what you're going to update about your process. So last time I remember I was a bit complacent with the earlier questions that I knew I could do, and it means I didn't save enough time for the harder questions that I knew were coming. So I'm going to want to go a bit faster through that, and then I'll explain it more afterwards if I need to. Apologies, my tablet needs a bit of charging. So that's the main thing I really want to work on. And I want to hunt more actively for any sort of case studies I haven't considered. Maybe use the mapping a bit more to just help me think of whether I've considered every possibility. So going through sharing screen. All right, 75 minutes on the clock, non-calculator. Start the clock, let's go. Okay, so the number of stationary points. Obviously, we're going to differentiate this. You're going to get 12x cubed and 12x squared and 12x. And for stationary points, it equals 0. So I could take a 12x out, x squared, and x and 1. Obviously, we have x equals 0. So the question is, how many solutions does this have? I'm going to take the discriminant there. So b squared minus 4ac is minus 3, which is less than 0. So this has no solutions, and there's only one stationary point, which is b for 1. Okay. Okay, so this one, question 2. Also, yeah, I just want to check this actually is paper 2. Yeah, paper 2, good. Expansion of this. Well, what's happening here? So that's 1 plus x to the 5 times the sum of that. So that's 1 plus x to the 5 times 0, by which I'm obviously mean 1, and x squared and blah, 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 blah to x5. So the coefficient of the x to the 5 term, let me drag, I can tell I'm just going to need more space for this. Let me just, oh, no. Just going to give myself more space to work on. Excuse me. So what we're going to do here, we know the x to the 5. So that's 1 plus x to the, sorry, that's not even, I've written that out wrong. Don't do that. 1 plus x to the 5. Well, I can do my binomial expansion on that. That's 1 and 5, 10, 10, 5, 1, knowing my Pascal's triangle. 1, 2, 3, 4, 5. There. Okay. So which ones are going to give me x to the 5 terms? That one. So we're just going to go across like that. So in other words, it's going to be 1, 5, 10, 10, 5, 1. So all of these are going to form x to the 5 terms. So it's then just going to be 1x5, 5x5, 10x5, etc. Add those all up, you get 16 times 2 is 32. And I think the answer is E. Okay, let me give myself more room again. Okay. So if n is prime, then this. Which of the following is a counterexample? In order to be a counterexample, the statement actually has to apply. So it doesn't apply to 3 because it doesn't apply. N is 4 is not prime, so we only have to consider 1 and 2. So for n is 2, n squared is 4 plus 1 is 6. So 6 is not prime. That statement is valid. So for n equals 3, then we get a thingy, the term is 11, which actually is prime. So n equals 3 is a counterexample. The answer is C, 2 only. So for 4, equation of a circle is that, where those are all real constants. Okay, let me just do some work to rearrange that. So f minus f squared, and we have y plus g squared minus g squared plus h equals 0. So we have x plus f squared, y and g squared equals f squared plus g squared minus h, which is r squared. Let the distance, L be the distance between the center of the circle and the point P. Well, the center of the circle is minus f minus g. And the distance to P, L, is going to be the difference between those, which is P plus f squared plus q plus g squared. And that's what L squared is. Which of the following is sufficient? Well, let me do sufficiency. So if the statement is, so a sufficiency mapping looks somewhat like this. If that is true, that only results on it being true. This cross term doesn't apply. So we are looking for something where if the statement is true, it only leads to being able to calculate L. So is there any way the statement is true and we could not calculate L, for instance? Okay, so if I know F, G, and H, no, that's sufficient for R, but not for L. Having F, G, P, and Q certainly does get me L. Let me just check the other ones, though. F, H, I don't need H to find L. I don't need H to find L. And E is sufficient. Okay, so yep, that's my answer. Straight line passes through there. Okay, so again, I'm going to use my mapping to make sense. If y-intercept is negative, and if the alternative of that is positive, then the x-intercept is positive, x-intercept negative. Let's find out what's actually true here. Okay, so let's write this out. So P so for instance, okay, let me, y equals mx plus c. We know it goes through, so this is true. So I can say that c is equal to 2 minus m. Plugging that back in, we have y equals mx plus 2 minus m. I can say that the y-intercept So the y-intercept, I'm going to call it 2 minus m. And the x-intercept, we solve for where y is equal to 0. So moving this across and dividing by m, we would get the x-intercept is m minus 2 all over m, which is 1 minus 2 over m. Okay. Now, those are the things I need to consider. Now, let me actually consider the statements. Well, first of all, let's work out what is true about these things. So if the let's work out the relationship between y-intercept and x-intercept. So for the and the x-intercept, if it is positive, negative, let's consider the mapping onto the x being positive and negative. So if the y-intercept is positive, no, negative. So that's exactly how they wanted it. So what is true here? If the y-intercept is negative, meaning that m is positive and bigger than 2, well, if m is positive and bigger than 2, then this term is positive and is less than 1, which does mean that the x-intercept must be positive. And that cross term doesn't exist. So P is true, which means the contrapositive of P must also be true. Now let's consider the converse of P, which is if the x-intercept is positive, then the y-intercept is negative. So if the x-intercept is positive, if this is true, then that must be true. But we can sketch 2 over m. And there are two cases. So either m is bigger than 2, or m is less than 0. And we can consider the consequences of that on the y-intercept. No, we can easily have, if the x-intercept is positive, we can easily have y being positive for when m is bigger than 0. So the converse is not true, but 1 and 3 are true. And so I'm going to lock in F as my answer here. Okay, necessary and sufficient. Okay, so again, let's consider P and Q and let's map this out. So let's work out the relationship between sort of n odd, n even. And for Q, the median of the list, median is in list, and median is not in list. Okay, so 1, 2, 3, 4. So if there's an odd number, then the median is the one in the middle. So if n is odd, then the median is absolutely in the list. And this cross term does not exist. If n is even, it can be in the list, or it could not be in the list. So what this tells us is that, this tells us two things. This tells us that n odd is sufficient. So P is sufficient for Q, but not necessary, which is C. Okay, let me give myself a bit more. Okay. The difference between two consecutive, how am I doing on time? Good. Not even 15 minutes in yet. Great. But I don't want to get complacent. So the difference between two consecutive positive Q numbers is always prime. Here's an attempted proof. So this is the correct cubing of x plus 1 cubed. The difference between two consecutive can we express as that. That is a correct statement. It is impossible to factorize that into two linear factors with integer coefficients. That's not true. That doesn't have to be true. If the discriminant is negative, it means it never equals 0. Wait. Oh no, is that true? I'll have a look at that. Therefore, every positive integer value of x. Therefore, every positive integer value of x, that integer cannot be factorized. Hence, the difference between two, it will always be prime. It is impossible to factorize that into two linear factors. Is that? Well, first of all, is that true? I mean, probably is true. Because the discriminant is negative. Well, let's actually just test that. So b squared minus 4c, it's definitely negative, which means when you have it's going to do something like that. Does that mean... I'm willing to believe that, but I'll come back to that. So I'll star 7. Come back to that with fresh eyes. But in the meantime, so this is a good time to use the technique of educated guess, but then coming back at it with fresh eyes. So here, I'm tempted to believe this is... Well, are there counterexamples? Well, it can't be completely correct if there are counterexamples. Let me try out the first few to just sort of see. So 1, 8, 27, 64, 1, 2, 5, 2, 16, 3, 4, 3, etc. Differences there, 7. Differences there, 19. Then we've got 37, which is prime. Then we've got 61. I'm willing to believe this is true. So I'm gonna educate a guess on A, and make a note to come back to that just in case. Because again, I want to do better than I did last time. Okay, so a selection N, and I wasn't making good traction, so it wasn't a good use of investment of time. So a selection S of N terms is taken from the arithmetic sequence. There are two distinct terms. Well, we know this arithmetic series is going to be 3n minus 2 is going to be the terms. So a selection of n terms from that, well, I mean, it's up to a point as well. There are two distinct terms in S whose sum is 74. There are two distinct terms whose sum is 74. A selection S of n terms. So we're taking n terms out of that, and there are two distinct terms in S. Oh, okay. So how many terms do I take out? It's necessarily true. Necessarily true. So it means it can't be 2. Okay, so let's say I find 2 terms whose sum is 74. I can't say the answer is 2 because I could select 2, for instance, 1 and 4, whose sum is not 74. How many? Okay, let's work out how many terms there even are in this. So that's n equals 1. So let's work out how. So 70 equals 3n minus 2. 72 equals 3n. So divide that by 3, you get 24. There are 24 terms in total. And this is going to be interesting as well. So let's write out a few terms from the front and from the back. So we've got 1, 4, 7. And from the back, we're going to have 70, 67, 64. we can see that this pair is going to sum to 74, and this pair is going to sum to 74, and this pair is going to. So every pair apart from the 1. So basically, the idea is we can group this into 3 things. There's the number 1. And presumably, then there's going to be, so there's 22 numbers that exist in the pairs. So there's the lower numbers than the upper numbers. And presumably in the middle, so in the n equals 12 or 13. So 12, no, so it's going to be 1, then it's going to be 11, so 12. So 13 should be out. So 13, 37. Good, because that 13 is there's not 2 37s in there. So there's going to be 1, the lower numbers, 37, the upper numbers. So what's the smallest value of n to guarantee that I pick a pair? Well, that would be, the most restrictive case would be I could pick the 1, I could pick the 37, I could pick all 11 numbers in there, and then I just need one number from there to be the counterpart to the 1 in there, and that's the most restrictive. So 1, 2, the 11 in here, and its pair in the upper one. So that's going to be 1, 11, 12, 13, 14. Brain is not yet fired up today, but I think the answer is 14, which is C, and I'm going to lock that in for question 8. How am I doing on time? 56 minutes. Okay. I think I got that right. And that felt like a good solve. So I'm pleased with that. That's giving me some confidence boost. Question 9. For all real numbers, okay, so we're considering x is less than k, and the alternative to that is bigger than or equals to k. And how does that map onto x squared being less than k versus x squared being bigger than or equal to k? Okay, but we're not considering just that. Okay, so for all real numbers, if that, then that. So this is the claim, is that if that, then that. So not if that and that. So this is the mapping of the claim that we're considering. So what is the complete set for which this is true? Well, what we need to consider is this. So what they're saying is this cross term does not exist. We can consider anything for which the cross term is true and exclude that. So where is it true that x squared is bigger than k? So let's draw x squared. Bigger than k. Well, it's root k so the cross term is true if x is less than k. Well, let's be okay, so here, let's consider numbers between 0 and 1 because I'm seeing lots of zeros and ones. So if k is between 0 and 1, if x is less than k, so let's consider, in fact, between 0 and 1, let's plop a k down. Then this would be the point k squared. So if x is less than k, let's consider between 0 and 1. No, I think I was right the first time. Let's drop, where is, because that's what I need to consider. So that is k, that is going to be root k, that is going to be minus root k. So it is certainly true that if x is less than minus root k, or if x is bigger than root k, sorry, no, we want where it's less than k. So that, in order for this to be true, then we need x to exist in this interval. This is the interval for which x squared is less than k. Oh, no, but we were considering, again, the cross term. So where... my brain is not locking into this. Okay, so if k is... Let's just do process of elimination. If k is bigger than 0, there are numbers for which x... Where is it true that if x is less than k... Okay, do you know what? I'm going to come back to this. Because I know this is doable, but I know it's not doable with the way my brain is acting right now. Okay. Let me not waste too much time on that. So, which of the following is true for all real numbers x and for all positive integers n? Okay, well, the first one isn't true, because it's certainly true you can have a real number that is bigger than a positive integer. So that's just not true. For all real numbers x, there exists a positive integer n such that n is bigger than it. That is certainly true. For every real number, you can just like round it up, take that integer, and that number would be bigger. So that's true. There exists a real number x such that for all positive integer n, x is less than that. Well, no. Because if we said that 3 was true, so let's say x was the smallest one, well, I could just consider x minus 1. So for instance, if it was x, and then all of the positive integer n's above it, well, if this first one, let's say this was n, if I subtracted 1 from this n, that would put me on the other side of x. It's just, yeah, proof by contradiction. It's just not true. It's just not true. So the answer to this one, to my mind, is very obviously 2 only, which is C. May not have explained that the best, but I definitely think that's the case. Now, okay, so let's go through 11. There's a kite. Yeah, we know these are perpendicular bisectors, so x and x, that makes sense. Which of the following is necessary and sufficient for SPQ to be a right angle? Okay. So we need, let me draw this out. So you won't be able to draw on the real thing, so I won't either. So let's see, why? Okay, so we want SPQ to be a right angle. So I'll call that A and that B. So what we would want is a squared plus b squared to equal the square of z plus y. But a squared is x squared plus z squared, and b squared is x squared plus y squared. And that is z plus y all squared, which means that 2x squared plus y squared plus z squared equals... Well, let me just see what I'm looking at here. Yeah, let's do some work on that. Because I can see that things are going to cancel out here. Plus y squared, cancel, 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 cancel. So it means that x squared is equal to yz. And I think the answer is C. Okay. So necessary and sufficient means just like locked on one-on-one must be true, solve it. And if that is true, then working backwards, I've shown that it is a right angle because Pythagoras works. And if Pythagoras works, so basically because I can work this forwards and backwards, it's a sort of if and only if necessary and sufficient. We'll explain more later if required. Now, place the following integrals. This is going to be fun. I think this is going to be fun. Is it going to be fun? I don't know if this is going to be fun. Right, so the first one, integral 0 to 1 of e to the ln 2 times x to the half I'm doing that because I know I can integrate exponential really easily. Um, do I definitely know how to integrate u? Let's use a substitution. X equals u squared, dx du equals 2u. So dx is equal to 2u du. When x equals 1, u equals 1. When x equals 0, u equals 0. So it becomes the integral from 0 to 1 as well of e to the ln 2. X to the half becomes u. Dx is 2u, which I can then do by parts. So first I will integrate that. So that becomes 2u e to the ln 2u over 2 between 0 and 1 minus the integral from 0 to 1 of that's meant to be ln 2 of 2 over ln 2. Let me bring this over so I have more room to work. 2 over ln 2 e to the ln 2u du. So plugging that in, we get 2 e ln 2 over ln 2 minus 0. And this guy over here becomes 2e ln 2 u over ln 2 squared with 1 and 0 as the limits. So then we have 2e to the ln 2, and e to the ln 2 is 2. So that becomes 4 over ln 2 minus I'm wondering if this was even worth it, or if I could have just but then I plug in equals 0. So it's 4 minus, so 4 ln 2 minus 2 all over ln 2 squared. I'm not sure this is how I'm supposed to be doing this. I think I could do this from graphing. I don't know. I'm not seeing a quick and easy way of doing this, so I'm just going to keep barreling through. So for this one, this would be the integral from 0 to 1 of e to the ln 2x dx, which is much simpler. So that just becomes e to the ln 2x over ln 2 from 0 to 1. Plugging that in, we get e to the ln 2, which is 2 over ln 2, minus e to the 0, which is 1 over ln 2, which is just 1 over ln 2. Okay, then this next one, r, is integral 0 to 1 of 2 to the half x, which is the integral from 0 to 1 of e to the half ln 2x dx, which again is very simple to integrate. So you end up getting e to the half ln 2x all over a half ln 2 between 1 and 0, which is e to the half ln 2, which as we established is root 2 all over ln of root 2 minus that times 0, e to the 0 is just 1 over ln of root 2. So it's root 2 minus 1 all over ln of root 2. Or rather, let's keep the half out. Let's multiply top and bottom by 2. So it's 2 root 2 minus 2 all over ln 2. Okay, so let's compare these. So 2 root 2, well, that's, so what we're comparing, so let's compare these two first of all. 2 into root 2 minus 1. Well, root 2 is roughly 1.4-ish. So that's less than 1, certainly. So R is less than Q. I know that much. Now, where does P slot into all this? So where are the options where R is less than Q? R is less than Q. Yeah, so it's just a matter of placing P in the mix. So that is P. Then that is the same as, well, let's say I hadn't multiplied that out. So that's 4 over ln 2 minus 2 over ln 2 all over ln 2. So to compare it, we need to consider how 4 minus 2 over ln 2 compares with both 1 and, well, let's start with 1. Well, ln 2, well, ln e is 1, and e is 2 point something. So if I draw a ln graph, apologies if you hate my pronunciations. So ln 1 is 0, ln of 2 point something is 1. So in between, this is very much less than 1. So that is something, how does that compare with 1? Equals 1 plus c. Let's solve for c. So what, 3 minus 2 over ln 2. Is that positive or negative? Oh, I should really have done this in the graph, shouldn't I? Can I graph these? Oh, that's so frustratingly. Okay. When x equals 0, they all equal 1. Can I differentiate that instead to find the graph? How am I doing on time? 40 minutes. I'm not feeling good about my pacing anymore. Okay, I'm going to say that feels... Okay, so let's consider 3 ln 2 minus 2. And whether that's bigger than 1. Three ln 2 so we have to compare ln 2 basically to 2/3. Oh, man. All right, I'm gonna, damn it. I've definitely missed the good solution here, but I'm gonna say that P is bigger than Q, and I'm gonna guess F, but then I'll come back to it. Make a note to come back to 12. Not great, but again, I'm only trying to beat my score of 14. So let me just do at least that and then try and go for glory. I've got 38 minutes to turn this around. 8 questions left. So I've got about 5 minutes per question. Let's see what I can do. 13. There exists a real number y such that this is negative. For how many real values of x is it true? So where is it true that this is negative? So that's, there exists, okay, if they're for, given a real number x, is there a real number y such that that is negative? So how many values of x can I find a y to make this negative? So I think, so let's consider x positive. When x is positive, is in this statement about a real number x, there exists a real number y such that that is negative. Why is my brain not braining today? Maybe it just is the paper. Right. Consider the statement about a real number x. Follow the idea. So if x is positive, okay, so can I find, so it's x into 1 minus y plus y. And we want where that is negative. So well, can there ever be a real number x for which there is never a y for which this is true? Okay, so x 1 minus y is certainly less than minus y. We then have two cases. This is true if 1 minus y is positive. Which means that 1 is bigger than y. And x is bigger than minus y over 1 minus y. If 1 minus y is negative, so if 1 is less than y. So if 1 is bigger than y, and I could probably have done the same thing for x. Let me do the same thing for x instead. Okay, so let me make y the subject. So that's x plus 1 minus x lots of y. And we want that thing to be negative. So we want 1 minus x lots of y to be less than x. And we want y to be less than x over 1 minus x. And that is true if. So I need to consider that if you can't divide, if you divide by a negative number, you change the sign. So y is less than x over 1 minus x if 1 minus x is positive, which means 1 is bigger than x. And the sign flips, that should be negative, of course. The sign flips if this thing is negative, so if 1 is less than x. It just feels like this is true for all values of x, but is there oh, I suppose Can it ever be equal to 0? My brain is not locked in. Not a good run. It's just not a good day for my brain. Maybe I should just come back and try it later. Oh, God. Okay. It's mainly because with a lot of these, it's not very clear how they want you to do this. Okay, so for numbers of x, which are bigger than 1, then there exists a number y where I just plug that in. I pick any, okay, let's try this. When x is less than 1, for all numbers x less than 1, I can calculate this quantity, pick a real number y less than that, and the equation will work. For all x's bigger than 1, I can calculate this quantity, pick a y bigger than that, and the equation will work. So then the only thing I need to consider is when x equals 1, and then I need to consider the quantity 1 minus y plus y, which is obviously just equal to 1, which is clearly not negative. So let me just check that works. So for any x bigger than that, so I can even try x equals 1.1. Yeah, I just plug that in. Okay, so it's not true for x equals 1. So it's true for all except for one value of x. Okay, I've turned... Whew. Consider the cases, Patrick. Come on. You said you were going to do that. Just do that. Implement your game plan. Right. What I really should have been doing is a bit more multiple passing as well. So I wasn't confident on that, so I should have maybe skipped. Make sure I get to all the questions I know I can do. So consider these two inequalities. Because I know I can do this. Okay, so where is that true? Let me sketch these. Modulus of x plus 11, something like that. X plus 5, something like that. And these are parallel. And x minus 5 is less than this for all x's. So this one here is what x plus 11. This is the negative case, so it's minus x minus 5. So where does x plus 11 equal minus x minus 5? When 2x is equal to minus 16, so when x is equal to minus 8. So this first inequality is true for all x being bigger than minus 8, the first one. And on the same one, we can actually draw, so that was 5, and these are, again, going to be parallel. So this is the x plus 1 modulus. So when is x minus 11, so the x plus 11 one is this one. When is this one less than this one? For all x's there. And again, we're considering in this one where x plus 11 on this branch is equal to minus x minus 1. So that means that 2x is minus 12 and x is minus 6. So they are... So the second one is true when x is less than minus 6. So drawing these on a number 9, we have minus 8, we have minus 6. The first one is true for x bigger, and the second one is true for x smaller than that. So there is the real numbers for which both inequalities form a length of 2. So the answer is D. Okay. All greater than 1 to satisfy the equations that and that. So what this means from the first statement is that x to the z equals y and y to the x equals z. Well, if I raise both powers, so if I do this to the x equals y to the x equals z, so it means that x so we want to take log z's of x. So log x to the x z equals z. And let's take log base z of both sides. So xz log z of x equals 1. Log z of x equals 1 over xz, which is f. Boom, not bad. Okay. Now. So these are 3 sequences of integers. So that is certainly true of triangles. So I'm wondering, okay, for each n. So these are a whole bunch of triangles. Which the following must be true. So for every individual, so let's say the A's do something like this. Then the B's and the C's, so for this minimum point, it is certainly true. Okay, let me get into this. So, okay, so at this minimum point, let's say that was A3. We know A3 is less than B3 plus B plus C3. Okay, let's try and find counterexamples is what I'm gonna try and knock these down. And that's gonna be the maximum. Okay, so let's start here actually. So let's say that A5 is the maximum. Well, that is less than B5 plus C5. If these are both the maximum, then the statement is true. If these are not the maximum, then there is a number bigger than it. So the statement is also definitely still true. So 3 is definitely true. Great, pin that down. Now, let's consider 1 and 2. So must be true. Well, let's say A3 and B3 and C3 are all the minimum. Then A3 is less than that, so 2 can't be true. So definitely not 2. Does 1 have to be true? Does that have to be less than the minimum? Can it ever be bigger than the minimum plus the minimum? So let's say B3, if these happen to all be the minimum, then that would be less than the minimum. It could be equal to, I suppose. So okay. So let's say we had, let's come up with an example. So let's say that so the A's one. How do I show this? So 1, 2, and 3 for A, B, and C. Let's say A1 was the minimum, but if that had a value, okay, so let's say that this had a value of 2, this had a value of 3. So this could be 4. Let's say that was the minimum. So let's say that was 5 and that was 6 on either side. Well, this is less than B, so but I could set that to be 1 and 6, and that would be true. And I could set this to be, I don't know, 7 and 1, and the statement would be true for A3. It would, but the minimum of A would be bigger than the minimum of that and that. So I don't think 1 or 2 have to be true. I think 3 has to be true, and I think the answer is D. I'm going to lock that in. I do not have fun in these paper 2s. 17. How am I doing on time? 20 minutes. 4 questions. Still on pace, but I've got something to come back to. A and B are non-zero real numbers. Okay, student solution. So we prove that this solution has 3 distinct real roots. So we know a cubic has 3 distinct real roots if the maximum point is above the x-axis and the minimum point is below the x-axis. So that's why they're differentiating. So you differentiate and they factor out an x. That is true. Solving for where the gradient is 0, we get x equals 0, y equals b. Good. And x equals minus 2/3, and then you plug that in. Do I take it as trust that that is case? X is, plug that into here. And so minus 8a cubed over 27 plus a into 4a squared over 9 plus b. Yeah. So that becomes 12 and 27. So it becomes b plus 4a. Yeah, this is definitely right. So if this minimum point hang on a minute. This depends on the sign now, because we don't know which of those is max. The one that comes first is the max. So we know it's a cubic. So the one that comes first has to be a maximum. But if A is positive, then this one comes first. Hold on. If that is less than 0, then they have opposite signs. So one of the stationary points is above, one is below. I suppose that's true. So I suppose it doesn't really matter the order. I like that. Oh. See, I do like this proof. I don't think... Because if this is true, then that, and if that, then these have one is below and one is above. So it is true that if this, then that, based on what they're saying. I like it. But let me consider this. The converse of the result in step 2. So should they have shown that if this, then that? I don't think so, because that should be going forward from there. converse of the result in step 3. Oh. Maybe that's right. Because we've proven that one of the stationaries is above the x-axis and one is below. And what they should have done then is said, okay, well, if one is below and one is above, then 3 distinct real roots. Why don't we go for that? So considering them using my multiple choice technique, I think the answer is E on 17. Okay. So stop trying to solve the math. Start trying to actually solve the multiple choice question. Timing, 16 minutes left. Okay, so the graphs have outrageous. Okay. Okay. Oh no, this is fun. Okay, so why don't we find, let's just plug in some special values. So pi over 2 one of them is going to be 0, and that is going to be sine x to the cos x. Because sine x would be 0 to the 1 would give me 0. So p, so cos to the cos, sine to the sine, cos to the sine, sine to the cos. We know that p is sine, cos to the sine. Sorry, 0 to the 1 is 0. Cos to the sine is p. Okay, let's try x equals 0. So 0 to the 1 is 0, so that is q. Okay, so now let's consider, so R and S, they've probably given every possibility, haven't they? Cos to the sine is, so these are the P's and Q's. Yeah, the R and S in some order. Okay. Gonna have to differentiate. I prefer differentiating signs, so let's do this. So dy dx on that d big, d small. So it equals cos x into differential of that no, I'm gonna have to change. I can't. Okay, so let's say y equals sine x to the u, where u is equal to sine x. So du dx is cos x. Oh, dy du. Oh. Okay. Maybe there's a better way of evaluating this. So let's consider pi over 6. So when pi over 6, I know that sine pi over 6 is a half. I know that cos pi over 6 is root 3 over 2. So we're considering a half to the half as compared to root 3 over 2 to the root 3 over 2. Well, that's the square root, so that's 1 over root 2. Now this is a higher number to a higher power. These are all between 0 and 1. So what happens when I take something to the power of something less than 1? Let me, okay. So Let's consider, for instance, 1 over 64. Let me take a third power of that is a quarter, and the half power of that is an eighth. So if the number is less than 1, taking a smaller power makes it bigger. And similarly, let me compare that with a 16th to the half. Oh, hello, Niels. I see a comment. Apologies, I track my comments a little less when I'm locked in, but I do see you. If you have a comment, feel free to place it, and I'll be a bit more diligent in the chat. So this was a quarter. So obviously a larger number. Just try not to backseat drive because I want this to be as honest as possible. This is not going well. Welcome to witnessing it. But hey, you're here, so okay. Let me try and use some exam technique to lock in and try and get a few more points, though. So we've got 12 minutes. I'm just trying to compare these things now. What do these tests show me about this? So this tells me that if I raise the number to so for instance, what this tells me is that a half to the half, if I raise that number to 3 over 2, that will make it bigger. So that is less than root 3 over 2 to the half. And then if I raise the power, no, if I raise the power, I shrink it again, but which one's going to predominate? Oh, man. Well, okay, so I know that cause is changing very little around the origin. So I'm going to suggest that the R is the cause one. So I'm going to say that's R. I'm going to say that's S. So you're a medical student. Okay, so RSPQ. Which one's RSPQ? RSPQ is E, so I'm going to lock in E. Okay, 9 minutes. Also, Niels, I will say I'm done with this run in 10 minutes, and then I will be much more attentive to you as opposed to the paper. Just trying to score every mark I can. So polygon has n vertices where n is bigger than 3. Every vertex lies on the circumference of a circle. The center of the circle is inside the polygon. The radii of the center, the vertices cut the polygon into n triangles of equal area. For which values of n are the properties sufficient to deduce that the polygon is regular? So we got a circle. We got some vertices. I'll just sort of draw it randomly. Equal area. For which values of n are these properties sufficient to deduce that the polygon is regular? Every vertex on a circle. So generally speaking, okay, will it do? So for which values of n will that just do to show it? So certainly, if they all lie on a circle, does that get, so for the sufficiency mapping, are they true? The sufficiency mapping looks something like this. There's none of that. So we just need to say that there's no way those can be true and it not be regular. So the center is inside the polygon. The polygon lies on the vertex is on the circumference. Radii from the center to circle C. Cut the polygon into n triangles of equal area. and triangles of equal area. How am I going to handle that quickly? The problem is with a lot of these, quick solutions don't come readily to the mind because you haven't seen ones like this before. So you have to come up with solutions on your own, and it's like not fun. So equal area. Oh, here we go. They would all be R. And the area of the triangle would be a half AB sine C for the angle in between. So the angle in between, well, sine C would need to be the same. Oh. It's certainly not sufficient for 4. Okay, I see what's happening. So basically, because for sine C, so for instance, I could make a rectangle inside it where like some of them were 30 and some of them were 150, and they would both have the same sine value. So I wonder if there's a way I can do this. So it's certainly not true for 4, but I think it could be true. It's certainly true for like, is it true for 5? Okay, so is it true for 3? Let's start there. So if 3, can I construct, I think if the center is in the middle, can that have been done? So for instance, can I make a circle like this? Yes, I think I can. Where those are both, say, 150. Oh, no. Can I construct it where 2... Okay, I'm wasting time on this now. But can it be done such that 2 sine of 180 minus x is equal to sine of x? No, okay, I'm overcomplicating this. I've only got 5 minutes left. So it's certainly not true for n equals 4, which means it's not C and it's not D. I don't think it's A because I think it really does work for large values. And because I think it works for large values, I think the answer has to be D. So my sensible guess would be D there. Because I want to give myself time with 5 minutes left to attempt the final question and go back for anything else. Well, that looks fun. This is combined math. This is specifically the TMUA paper. So this is for entrance for math and for a lot of economics. It's a specific entrance test. So functions are defined. Okay, 4 minutes left. Where all numbers are taken to be radians, these functions have maximum values of those. Okay, we know m1 is equal to 1. For 20. Sine of cos x. Well, there's nowhere where that so that is certainly less than 1. Cos of 0 equals 1. So I can make, well, cos of 0 equals 1. When can sine, this spits out 0 when cos x is 0. So if x is equal to pi over 4, or pi over 2 even, this is 0, sine of 0 is 0, cos of 1 is, yeah. So certainly true. And then same thing here, I think. So can I get cos of 0? So if that is pi over 2 again, then that is 0, sine of 0 is 0. Oh no. So I think we're talking about E or F then. And then we only need to consider M2 versus M4. I don't think they'll be the same. I've got 2 minutes. I'm going to go for F on 20. And then I'm going to go back to 12 or 9. So I didn't have time. So I got to quickly get things inputted. So I put something down for 12. I did not do 9. Let me quickly, I've got a minute and a half. Let me lock this in. I just want to give myself a chance by putting in an answer. Okay, so here, if k is bigger than 0, between 0 and 1, I'm going to go for F. Because I think it can be equal to 1. And I don't think it's true. Out of those, I think I like that. Got a minute left on the clock. I don't think I'm going to get anything meaningful done in this minute, so I'm going to stop the time there. Ugh, again, another unfun run. All right, Niels, I'm with you now. I'm going to go through the answers, but I'm going to be much more looking at the comments if you want to comment anything else specifically. Let me go through. Well, I got the solutions. I probably should have just looked at the answer key, but whatever. So let's go through, because I'm curious to see what they say about that. Let me first just mark up. Well, actually, no, we'll go through one by one. So here, question 1. This is going to be humbling. So determine the stationary points. This was fine. Differentiate, set to 0. This quadratic had no solutions because the discriminant was less than 0. So there was only the one turning point. Great. Lock that down. B, that was correct. Question 2, I got E. Yep, so that method was correct. You can actually just multiply it out and realize that these cross terms, so this x to the 4 times the x is going to give you x to the 5, x cubed times x squared is going to x to the 5, etc. And so you can see all those cross terms are going to give you your x to the 5s. So it becomes 1 plus 5 plus 10 plus 10 plus 5 plus 1, which is 32. So that was fine. Question 3. I said C, and I got that correct. It's not prime, so the statement isn't made about that. Good. 2, it works. 3, it doesn't work. So 3 is the only counterexample from those given. Question 4. The option is B. Good. For exactly the same reason. I just got an expression for L squared. And then I needed PF, Q, and G, so that worked. Great. So the next one, I said F, and I got that correct. Let me go through that in maybe a bit more detail. Well, what I did here, this is the one where, for question 5, so we're good. Like, as I'm going through, I'm going to talk about the ones I got right, but also really focus on the exam technique for where my brain was just going really, really wrong. So here, what did I do? So I got this one right. I said if the y-intercept of L is negative, so I found a general equation of the line. I knew it went through the point, so I plugged that in. So I got C in terms of M. So the y-intercept was 2 minus M, and I got the x-intercept. And I said if that is negative, Well, yeah, I said if that is negative, so if m is bigger than 2, then x-intercept has to be positive. So it is p was true, which means that 3 had to be true as well, because the truth of the contrapositive is the same as the truth of the statement always. And then I just considered the converse, and I found that the converse didn't have to be true because there was another condition. So satisfied with that for f, for 5 even. Then for 6, the answer was, yep, it was C, because it's true. This was the mapping, and that is the sufficiency mapping. It is true that if it is odd, then you absolutely get something in the list. And it is true that if n is odd, you never get a number that's not in the list. So the only thing we need to test for now is necessary. Is it possible that n is even and you get something in the list? The answer is yes. You can just sort of make that happen by making the two numbers in the middle the same thing. So an example of when that's the case would be 1, 2, 3, 3, 4, 5. The median would be 3, which is in the list. So that works. So far, so good. The wheels are going to fall off at some point. I'm just wondering when. Question 7. Yeah. Here. The proof is wrong, and the first error occurs in line 4. I did say 7 was the one to come back to, so I wasn't super confident on it. So just because it can't be split into two linear factors does not mean that the number cannot be factorized. Oh, with integer coefficients. God damn it. Yeah. Okay, what are they saying here? So for line 3, we could write that with real coefficients. Then we would have roots. The discriminant is less than 0, so this is impossible, so the statement is true. Yeah, line 4 is more tricky. You don't say solutions. All right, line 4 is tricky. Just because the algebraic expression is not factorizable does not mean the integer it represents is not factorizable as integers. Okay, so what they did was rather than see if it follows through, they just came up with a counterexample line by line. So that's a useful technique I can pick up moving forward. And what I should have done, well, I did the right thing by skipping this and using my time for where it was more likely to yield marks. I think I should be more ready to do that, because just because the question was earlier does not mean it was necessarily easier. So I should have been skipping that a bit quicker. So 8. The option is C, and I got that correct. I really liked this solve. So they recognized as well that there were pairs. So there was going to be 1, there was going to be 37, and then there were going to be the pairs. Also, Niels, if you have any specific thing you want me to sort of go over in a bit more detail from this, do let me know. I can kind of tailor it more to you because you're actually here. So I'm going through this one. I really liked this solve. And I think I'm satisfied with how I explained it, that they were, in order to make, so explaining question 8 again, all of these numbers, there are two distinct terms whose sum is 74. I can make the 74 in pairs. So the 70 and the 4 make 74. The 67 and the 7 make 74. So there's 11 of these pairs in there. 37 doesn't pair up with anything else. 1 doesn't pair up with anything else. So it's 11 numbers. 37, 11 numbers. And the worst case scenario is I pick the 1, the 37, all of these 11, and then the next number, the 14th number I pick, has to be a number that pairs off with this to make 74. So that's why the answer was C. That was cool, and I liked that. So let me mark, I got 7 wrong. I'll just keep a note of which ones I got wrong. So moving on to 9. Oh, I wasn't confident on this one either. Let's see if I guessed my way to a correct answer. 9 was A. Didn't do it. So the statement does not restrict us to positive real numbers. We can always find a large number k. Is this true for no real numbers? For values of k? Damn. All right, let me find out what I did wrong there. Positive real numbers x. That is certainly true. Oh my god, it had to be for all real numbers x. So it's never true. Oh, that was silly. Because I wasn't thinking about the x, moving x and moving k independently. Okay. So in other words, for any value of k that I set, I can arbitrarily say maybe I'm getting the if then wrong. Yeah, I think I can say that if if x is less than k, so this is an x that is certainly less than k, but x squared is bigger than k, and I can do that for every k that I set. That was silly of me. I just didn't, I could tell at the time it wasn't locking in properly. Okay, but so hopefully I get some others right though. So, oh no, I got this wrong. No, I'm looking at the wrong question. 10 was A. No, I did get this wrong, but for different reasons. So 10 was G. Oh, so it was 3 as well. Oh, positive. Oh my god. What? I didn't read the word positive. That's just bad exam technique. Dude. No. That's frustrating because of course that's true. So any real negative number x that's true for. That's bad form. All right, I apologize for that. That's just bad. But I still want to beat my score of 14. 11. Come on now. C. Okay. And I'm hoping as well, I'm not afraid of making these mistakes publicly because I think my mistakes can be instructive. You can learn, it tells you that making these kinds of mistakes is easy. Everyone does it, even if you're like a professional. It's just a matter of practicing enough that you decrease them over time. But also, like, you can then learn from the mistakes that I did and hopefully get better. I did not like 12. I'm really curious to see what their fun way of doing that one was. 12. What did I settle on the end? F. Oh, thank God. But how was I supposed to have done this? We do not know how to integrate any of these. Speak for yourself. Let's compare the integrands as integrals. Oh, okay. Okay, so how should I have done this? So 2 to the root x is 2 to the... Root 2 to the x is 2 to the x over 2, certainly. So in that interval, x over 2 is always less than that. So that makes sense. X is less than root x. That would have been much easier. Yeah, I wasted a lot of time on that. I could feel it. I could feel that I wasn't doing the most elegant solution path there. So I wasted a lot of time on that, and I should have just done that. If anything, I was sort of let off by the fact that I actually could perform those integrals, and I tried to actually do that. I didn't think about the fact that they wouldn't expect you to do that, so it had to be a different path. That's interesting. So if anything, those of you doing further math might get put off by that. So what they're saying is, here, getting my little pen tool out. They're saying, and this is a really interesting idea, that this is 2 to the x over 2, and in this interval between 0 and 1, x over 2 is always less than x. So these values will always be less than these values, so r has to be less than q. And what they are also saying is between 0 and 1. So let's compare, for instance, a quarter and the root of a quarter, which is a half. Then in this interval, x is always less than root x in the interval that we're considering. So in terms of the powers, it would be 2 to the x over 2 would be less than 2 to the x, would be less than 2 to the root x. So there was a much easier way there, but I did at least get it right. Pleased with that. So that was good guessing on my part. Good sort of educated guessing. That was I mean, you look at how much work I did there. It was obviously not how you were meant to do it. 13, I landed on, it looks like I landed on E. And I wasn't confident on this one either, but I got it right. Boom. So I did work my way to the correct solution there. How did they do it? A function of y, certainly. So they rewrote it this way. Which is just my plus c. Oh, I don't like that. I don't like that at all. I do actually prefer my method there. But it is certainly true. I came out, so I did it by considering the inequality. I considered it for x is less than 1. I considered it for x is bigger than 1. And it's true for all of that. The only thing I hadn't considered was x equals 1, and I showed that that didn't work. Great. E, locked it in, got it, nailed it. D, got that one too. This I'm much more confident in. You just sort of sketch it and it works out. So this I felt good about. So just working on your modulus. And if I'd done a multiple pass technique, if I'd skipped all the questions I didn't like, I could have come to this sooner and built up more of a time bank. But I did get it right. So into 15 now. I said F, and I was happy with my solution path here, actually. I think that was pretty well explained. 16. Oh, I hope I got this right. Option D. Oh. Oh, I feel good about that. Woo! that one stressed me out, guys. I mean, these questions, they're hard, and it's a worthy challenge, and it's good to sort of best it. All right, like that feeling. Let's go to 16 and do that in a bit more detail. I liked my explanation for the maximum, why that had to be true. I liked my counterexample. Yeah, so that's what I did. I just tried to come up with counterexamples, and I managed to come up with one. So in these examples, where if all the other ones have numbers that are all bigger than this, then the minimum A would be 4. But I can engineer it such that the minimum of B is 1 and the minimum of C is 1. And if you add those up, you get 2. So I can engineer it such that the minimum of A is bigger than that, so 1 doesn't have to be true. And you can also engineer it such that if all of them are minimum on the same incident, so if A1 was the minimum and B1 was the minimum and C1 is the minimum, you can easily construct it such that 2 doesn't work either. But 3 has to work because it just has to work. Because at the very minimum, then A5 is less than the sum of these guys. And the only other option is if these are the maximum, then the statement is true, or there are numbers bigger than that, in which case it's even bigger than this, and so it's even more true. So 16, I was pleased with that. 17, again, I did not feel confident. And I would have, my gut reaction was to say, yeah, that's right, and was going to say it was correct. But at this time, I actually did go through step by step and consider it, all the possibilities. So I hope I talked myself into the correct answer here. I hope it was E. Yes. So the correct option is E. And I wouldn't have gotten onto that if I hadn't read the multiple choice solutions first. Okay. So it seemed correct, but in terms of the logical path, if we're saying if this, then this, then what we have to do is to start here and make conclusions. So if that, then these, then opposite sign. And what is supposed to happen, then go from opposite sign to distinct roots. But what they did is they went the other way around. They said if distinct roots, then opposite, and this, then opposite. So it works. But it doesn't follow through. The logic doesn't follow through from start to finish. So the converse of that should have been considered. Which is, whew. Okay. So I'm guaranteed matching my score from before. So for 18, is the option E? Yes, it is. And now I've guaranteed bettering my score. Now, exactly, I didn't, so the first ones were easy. The P and the Q were easy, but I didn't think of a quick, good way of comparing those. Yeah, the first of these looks horrible. I quite agree. But we can approximate the value of the second, which is just 1 over root 2. Oh, God damn it. So 1 over root 2, yeah, I should have clocked that. So on one of them, we have the point. So the way I ended up arguing this was about, I didn't differentiate them explicitly, but I did do it sort of get a loose feel for it. That cause is varying very slowly around 0. So the body would be varying very slowly, and the power would be varying very slowly. So I would expect it to be varying not too much here. Both of these have a gradient of 0 at x equals 0. So I'd expect it to basically not be changing around 0, which is why I thought the form of R felt more like a cos to the cos. Whereas here, I knew that sine was changing a lot. So the body would be changing a lot, and the power would be changing a lot around x equals 0. So that felt more like a sine-sine curve. 19. Well, we shall see. I'm confident I got it right that n does not equal 4. I'm pretty confident that it is true for large values. And I'm pretty confident that means the only option available was D. But we'll see if I was right. Ah, it's B. Okay, so I wasn't right about the... Okay, so I remember I was low on time, so it was a pretty good educated guess. So I knew it didn't work for n equals 4. If I'd had more time, if I hadn't botched question 12, I might have had the time to consider this more thoroughly. How did they do it? I knew I was onto the right idea. So how did they... So I got 19 wrong, but I'm okay with that because I did well under time pressure. So that is definitely true. All the triangles will have equal area if and only if sine theta is the same. So this idea of the x and the 180 minus x was still true. I don't know how you would do this quickly under time pressure if you had 5 minutes left at the end. Oh my god, this is awful. Ugh. I mean, all of this is true, but like, remember, my run is not. This is about my. I'm all about exam technique, and I'm not sure I would have thought about that in the real thing. That's bananas. I suppose what I could have done instead is to just argue. Well, I suppose for it to not be what you would expect for a large n is for all of them to be obtuse. So could I just arbitrarily make one of them acute and see what happens? So for instance, could I do something like this? If I was going to make it acute, so it would be. I'm not sure how that would work actually. Okay, so I'm literally not even going to consider this. I'm just going to say congratulations, you win, you beat me. What about 20? So I think I narrowed it down to E or F. I went with F. Was I correct? The answer was E. So I was deciding whether these would be equal, M2 and M4. Okay, so with a bit more time, so the maximum there is sine of 1. Can I make that equal to 1? Yes, when this thing is 0. When does that... no, I could have, with a little bit more work. No, I did have the seconds to spend on that. That's frustrating. I was so close to that. Because what I could have just done is to say, what is the maximum here? The maximum here is sine 1 when cos x equals 1, which is when x equals 0. And can I make a sine 1 here? Yes, when cos is 1. So when sine of this equals 0, which is when cos x... Oh, no, that's what I argued. Oh, no, when cos x equals 0, when x is pi over 2. So that would be 0, making that 0. Cos of 0 is 1, sine 1. Damn it. Oh, I was so close. Okay, so I've increased my score to 15 out of 20. Upward trajectory. Was so close to making it 16, and I want to get further still. Now, 19 and 20, I missed out because I was time pressured. So that 20 I absolutely would have got. So that's exam technique. I needed to give myself more of a time bank. And what I should have done is skipped 12, because if I skipped 12 and allocated that time to 19 and 20, I could have traded that correct answer for 2 correct answers, and that would have been a good trade. So those 2 at the end was just exam technique. Now, what happened here in 7? Because that was the thing. 7, 9, and 10 all went badly, which knocked my confidence. So when doing a proof, try and counterexample every... That seemed like too bold a claim, and I should have known that, and I should have gone into that. So if something seems like it's saying too much, actually go in and counterexample that. So that's exam technique number 1. This was just me not reading the question, which was annoying. And this was, again, me not reading the question, which was annoying. So I definitely have the potential to do better, because I feel like some of the complicated problem solves I got right. But you're going to, like, I'm going to go through this with you, where TMUA is not my usual bread and butter. So I'm going to, like, let's do it together. I am making mistakes, but I'm getting better. You are making mistakes. You are getting better. Let's see if we can refine this. So by the time we hit the TMUA in January, we've got an absolute game plan that is absolutely going to work to maximize the potential. I'm going to stop there. I'm also going to do some paper ones, because it balances out with the paper one. So I think if a paper one goes better and paper 2 goes worse, it's kind of like, But okay, I'll leave this up. There was genuinely a point in the middle where I was like, "Oh my god, I'm actually going to take this down. No one can see this. This is awful." But 15 out of 20, it's an improvement, and like I was close. Like if I'd read a couple of questions better, if I'd used my time better, I would have given my questions at the end a bit more time to breathe. Um, that was doable. That was doable. I'm certainly closer to doing a good run. For me, a good run would be like 18 out of 20 is really what I want to target. But I definitely want to get a 20 out of 20 run if possible. Um, and so I know what I've learned from that. I know what to implement next time. And this is how to demonstrate how you can go through a session, how you can use a paper, dissect it, pick up the skills you need moving forward. So last time I picked up um, looking at the specific case studies a bit better. I realized I hadn't understood the contrapositive. Contrapositive came out this time. Boom, sorted it. Knew what I was doing because I'd learned it. Right. Um, Yeah. So same thing here. This time it's all about time management and really reading the question, especially if I seem stressed. What I should have done is skipped it. I could have come back to it with fresh eyes and realized a bit better what was being said. Like, oh, okay, it meant for all X, blah, 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 blah. Yeah, I think that's it. I think I know what I need to do for next time. So I'm going to implement those changes. Um, and yeah, we'll see how it goes. All right, we'll leave it there. Hopefully you've gained from this. Um, and I might redo. No, I won't redo anything. Yeah, we'll just leave it there. All right. Take care. Work hard. Have fun. I'll see you guys next time.